Hello, I'm Ashley Rice.
And I'm Melinda Rose, and this is Light Matters for March 13th, 2013.
On today's show, spectroscopy could lead to better optical devices, a laser test for breast cancer readies for human trials, an IR camera detects the main cause of acid rain, the UK backs funding photonics for healthcare, and the winner of a student prize has a lot to grin about.
A new method called energy momentum spectroscopy, developed by a multi-university team, provides a better understanding of the orientations of light emitters in layered nanomaterials and other thin films. The ability to distinguish these orientations could lead to better optical devices such as LEDs and solar cells. Analyzing how light interferes at different angles, one can draw conclusions about the film itself, how thick it is, for example. This new technique takes that analysis one step further by looking at the energy as well as the angle and polarization at which light is emitted. The technique was demonstrated on two important thin film materials, a 2D material similar to graphene and an organic semiconductor. Each represents a class of materials that shows promise for optical applications. Once the orientation of the emitters is known, it may be possible to design structured devices that maximize those directional properties. The research was published in Nature Nanotechnology.
A test used in security scanners to detect liquid explosives could also determine if breast tissue is cancerous. The UK-developed method, known as spatially offset Raman spectroscopy, uses a laser to pinpoint objects deep beneath the skin without an incision. It measures signatures obtained as light passes through the small bone-like crystals in breast tissue to determine whether it is benign or cancerous. Currently, when a mammogram picks up abnormalities, a follow-up needle biopsy is required, but 70 to 90% of those tests come back negative. But the new laser technique, developed earlier at the Science and Technology Facilities Council's Central Laser Facility, could eliminate the need for a second hospital visit and the anxiety of waiting for results. Under an ESPRC grant, investigators hope to optimize the technique's sensitivity and penetration depth further and, for the first time, evaluate its performance on human breast tissue that has been removed during operation. It will be a decade before the test can be routinely used in hospitals.
A new infrared camera that detects sulfur dioxide and other pollutants could help identify and control such emissions at an early stage before significant damage is done. The new camera, based on technology developed in Spain, detects and measures sulfur dioxide, a main cause of acid rain, among other compounds. Although several instruments for detecting gases are on the market, none offer the ability to determine the individualized concentration of each gas that is present in the mix, and at the same time from a distance and in real time.
The UK's Technology Strategy Board will invest up to $5.5 million in projects that apply innovative photonics technologies to challenges in the health sector. The two-part competition was announced this week by Minister for Universities and Science, David Willetts. Because the funding wants to encourage new partnerships between industry, academia, and healthcare providers, the project must be business-led and collaborative. The first part is a single-stage process for feasibility studies. The second part is a two-stage process for collaborative research and development projects. The competition is now open, and the registration deadlines for both stages are in April.
A materials science and engineering student who developed a method to manufacture brighter, more energy-efficient LEDs is a recipient of the $30,000 Lemelson Rensselaer Student Prize for 2013 from Rensselaer Polytechnic Institute. Ming Ma is among three prize winners announced this week from MIT, RPI, and the University of Illinois, who demonstrated inventiveness by creating or improving a product or process. With his project, Graded Refractive Index Structures for Brighter and Smarter Light-Emitting Diodes, Ma created the first viable approach for high-efficiency LEDs with a controllable far-field emission pattern, an important development for LED lighting. One of the technical shortcomings of today's LED materials is low light extraction efficiency. By inventing a process for creating LEDs with many tiny star-shaped pillars on the surface, Ma minimized the amount of reflected light while boosting emitted light. His patent-pending technology, called GRIN LEDs, has demonstrated a light extraction efficiency of 70%.
That's it for this edition of Light Matters, Photonics Media's weekly newscast.
As always, you can write to us with your comments or questions at lightmatters@photonics.com.
Thanks for watching, and we'll see you next week.
Nano is Greek and means dwarf, so it's something that's extremely small, of the order of 1,000th of the size of a hair. And we're working at this level in order to induce changes in protons that we all consist of, more or less. We have 30 to 50,000 protons synthesized by our cells constantly. Now, with light, we can work also with cancer cells, and it turns out that cancer cells, they die if we use a specific wavelengths and a specific intensity of the light. These cancer cells simply die. And our hope here is that we can use this knowledge to improve the chances for people with skin cancer and other type of cancers that are sitting on the surface of tissues that we can reach with an optical fiber. So, and that would be a beautiful way of using your knowledge.